So here we have a question and we are going to solve it all together one on one, right? Okay. Let's read the statement first. A sugar syrup containing sugar and water only, right? Of weight 214.2 gram contains 34.2 gram of sugar, and the formula for the sugar is C12H22O11, right? Find the mole fraction of the sugar in the syrup, right? So we are going to find out the mole fraction of the sugar, which is going to be, what is the formula for the mole fraction is moles of sugar upon total moles, right? And because it is written in the question statement that we have sugar and water only, so I can easily replace the total moles with moles of sugar plus moles of water. Now the task is to find the moles of sugar and water, right? So what is the formula for moles? We are provided with the masses, right? So the formula for moles is in terms of mass. What it is? It is given weight upon molar mass, right, people? Okay, okay. So given weight for let's calculate it for sugar first. So given weight for sugar is 34.2 grams. Can we just calculate the molar mass of the sugar? It is C12. Let's do it here. So the atomic mass for carbon is 12 and we have 12 atoms of carbon or 12 atoms of carbon in one molecule. So 12 into 12 is 144. Okay. Then you have 22 hydrogen. For one it is 1 gram per mole, so 22. And then it is going to be oxygen, which is like what? 11 into 16, 176. You need to add them all. So answer is going to be what? 6, 4, 10, 2, 12, 4, 7, 2, 9, 10, 14, and 111 is 342 grams per mole. So let me write it 342. So the moles of sugar is going to be 34.2. Easy calculation. 1 by 10. Okay, this is fine. Let's calculate the moles for water as well. So for moles of water, what do we need to do? We have to subtract the mass of sugar from the mass of solution, right? So let's first calculate the weight of water, right? The given mass of water. So how you gonna do that? 214.2 minus 34.2, 0.2 cancel, 440, 21.3 is like 180 grams, right? So if I just calculate, let me remove this part. If I just calculate the moles of water, then it is going to be what? Moles of water will be the given weight of water upon molar mass of water, that is nothing but 18 gram per mole, right? So 180 by 18, again very simple calculations, 10 grams per mole. 10 mole is going to be the moles of water, right? Let's put the values now, final time. So moles of sugar, we have calculated it over here, 1 by 10, fine. Moles of sugar, 1 by 10 again, and moles of water is 10, fine. So if you just solve this, this is going to be 1 by 10 divided by 10, 10, 100, 101 upon 10. Cancel 10. Answer will be 1 upon 101. Okay. So if you look at the options, okay. The answer is in scientific notation. So let's convert this with simple approximation. Let me write it over here. Let me remove this. Let me clear this one so that I have some space to write. Okay. So if I just do it like this, I'll approximately take it 1 by 100, right? So this will be nothing but 1 into 10 raised to power minus 2. Okay, 1.999. Okay. So can I just write it as what? I have assumed 101 as 100. So can I just say that if it would have been 101, then this fraction is going to be slightly less than 1 into 10 raised to power minus 2. That means it is going to be 0.9 into 99 into 10 raised to power minus 2. So if you just convert this, it will be 9.9 into 10 raised to power minus 3. And what will be the unit for mole fraction? No unit at all. There will be no unit. Why? Because this is a ratio of moles. So there will be no unit for it. And the final answer is 9.9 into 10 raised to power minus 3. Option number B for Bombay or Bangalore or BYJU'S as well. Thank you. So here we have an international level question, and let's see how is it. So on a ship sailing in the Pacific Ocean, okay, where the temperature is 23.4 degrees C, a balloon is filled with 2 liter of air. Okay, okay, fine. What will be the volume of the balloon when the ship reaches Indian Ocean, where the temperature is 26.1 degree C? Fine. See, try to understand this thing. When there is an ocean at sea level, if a ship is moving, when it moves from one weather condition or one ocean to another ocean, obviously, according to the weather conditions, the temperature is going to differ, right? And that's what we can see from 23.4 degrees C to 26.1 degrees C. This is the change in the temperature, right? Okay. But one thing you should keep in mind, what? That when you are moving on the same sea level, then atmospheric pressure is going to be on practical basis is going to be same. It is more or less same, right? So if I say that pressure is constant, then by applying the Charles law, when pressure is constant, we use the Charles law. And can I say, according to Charles law, what is the formula for Charles law? Come on. Recall that. Yes, yeah. It is going to be V2 by V1 is equal to T2 by T1, right? Volume is directly proportional to temperature when pressure is constant and moles of gas is obviously constant. Okay. So if you utilize this particular formula, this equation, then can I say that V2, the final volume of the balloon is going to be V1 into T2 by T1, right? Okay. So temperature is given in degree C, and because it is the absolute value here, so you have to convert that. So let's convert. T1 is 23.4 plus 273. We have to convert that into Kelvin. So it'll be like what? 0.4. I'll write it here. 336,729, 296.4 Kelvin. This will be your T1, right? Okay. If I just convert T2 on this similar parallel lines, 26.1 added to 273, this is like 1,639,729, 299.1 Kelvin. Okay. And V1 given is 2 liter. So my answer is going to be in liter. So no need to change that. So it will be like 2 into T2, 299.1 upon 296.4. Pretty close. And answer will be in liters. Okay. Okay. So if I just solve this, can you just observe this thing that this is 299 divided by 296 approximately, very close to something which I call 1.2 into 1 point, let's say what, 01, right? Very close. So if I just multiply this, 2.02 liter is going to be the approximate answer. And if you just match with the options, 2.018 pretty close to 2.02, 4.036 far away, 8 point something very far away, 9.5 further far away. So the best possible answer is option A, and which is going to be the right answer. So with that, we conclude this question. Thank you. Yeah, so here we have a question from equilibrium chapter. Let's see what the question says. And Kp is equal to 0.04 atm at 899 Kelvin. Okay. For the equilibrium shown below. And where is the equilibrium? Okay, here is the reaction given to you. This reaction is like ethane gaseous state converting into ethene and hydrogen in gaseous state, right? And a saturated hydrocarbon converting into an unsaturated hydrocarbon with the removal of hydrogen gas. Okay, this is fine. What is the equilibrium concentration of ethane when it is placed in a flask at 4 atm pressure and allowed to come to equilibrium? Okay. See, try to understand one thing very clearly, that at initial moment you have only and only ethane gas in the flask, right? So the initial pressure 4 atm will be nothing but the partial pressure of the ethane gas. Okay, this makes sense. So if I just write this data, you have C2H6 ethane, and then this is the sign of a reversible reaction, right? Equilibrium always comes in a reversible reaction. Is converting into C2H4 gas and then hydrogen gas. If I say initially at T is equal to 0, I have only ethane gas, so the pressure was 4 atm, right? And ethene and hydrogen was 0. Fine. If you go PV is equal to nRT, and if I assume that the volume of the flask is constant, then the pressure is directly proportional to moles. The temperature is given constant. You can see it here that it is 899 Kelvin fixed, right? The temperature is constant, the volume of the flask is constant, so pressure is directly proportional to moles. So if I say that when the reaction moves forward, then some amount of ethane, let's say a moles of ethane gets converted into ethene and hydrogen, right? And according to the stoichiometry, if a amount of ethane converting into ethene and hydrogen, then a amount or a moles of ethene and a moles of hydrogen will be formed. Can I, using this relation, can I say the similar thing is going to happen with the pressure? Let's say the pressure reduces by x atm, right? So the at equilibrium, the pressure of ethane is 4 minus x atm. Then the pressure of ethene will be x atm, and the pressure of hydrogen is also going to be x atm. I hope this makes sense. Okay. Okay. Now let's write the formula for Kp. What is the formula for Kp? It will be like partial pressure of moles. Oh, sorry. What is the formula for Kp? It will be product of partial pressure of product raised to the power stoichiometry upon the product of partial pressure of reactants raised to the power their stoichiometric coefficient. I hope this makes sense. So Kp here will be partial pressure of C2H4 at equilibrium into partial pressure of hydrogen at equilibrium upon partial pressure of ethane C2H6 at equilibrium. Okay. So if you just put the values, Kp is given as 0.04. Okay. Pressure of ethene is X, hydrogen is X, C2H6 4 minus. If you just solve this, so 0.4, I'll say this will be 100, this will be 1 by 25, cross multiply. So this will become, let me remove this from here, and 4 minus x will be equal to 25x square, right? Okay. Okay, let's solve this further. This is going to be a quadratic equation. 25x square plus x minus 4 is equal to 0. Do we have some roots? I don't feel like. So let's use the formula. X is equal to minus b plus minus under root b square minus 4ac upon 2a. I am sure you have studied this formula in your previous standards. So minus 1 plus minus b square is like 1 square minus 4ac, 4 16 plus, and 16 into 25 is like what? 25 into 8, 200, 400 upon 2a, 2 into 2, 25, 50. Okay. Okay. Let's solve this further. So this will be like minus 1 plus minus 401. So can I, let me write 401 upon 50. So if you solve this further, this will be like what? Minus minus. Obviously, the value of x, which is pressure, cannot be negative. So I'll neglect the negative sign. This will be only plus here. So minus 1 plus. If I assume 401 to be 400, then the root of 400 will be what? 20 upon 50. So 20 minus 1 is 19 by 50. 1.9 by 5. This is going to be what? 19 into 2 is 38.38 atm. This is the value of x. Is it going to be the final answer? No. What you have to find is the value of 4 minus x. The partial pressure at equilibrium of C2H6. This will be 4 minus 0.38. 4 minus 38, 3.62 atm is going to be the final answer. Let's match with the options. 3.62, yes, it is here. So option B for Bombay, Bengaluru, or even BYJU'S is going to be the right answer to this question. And with that, we conclude this question. Thank you. Here we have a question on mixing of acids, and we are going to solve it together, right? So the question says the 10 ml of M by 200 H2SO4 is mixed with 40 ml M by 200 H2SO4. Okay, both the acids are same. So the pH of the resulting solution is, so you have to find the concentration of H plus in the final solution mixture, right? And then you have to apply the negative of logarithm, and then final the pH will come. Okay, this is going to be the course of the question. Let's start doing it. So let's say this is solution 1 and this is your solution 2, because both of them are acids. If you just mix them together, moles are going to get added, right? So can I say N1 plus N2 is equal to N3? If this would have been the case of acid and a base, then it is going to be N1 minus N2 is equal to N3. That will be neutralization, but because both of them are acids, they are going to add up, and this is going to be the basic equation, right? Okay. So if you just see molarity, the formula for molarity is moles by volume. Okay. And you have molarity, you have volume in ml. Here volume is in liter. Keep that in mind. So moles will be molarity into volume in liter. Fine, fine, fine. So can I just write, instead of N1, M1 V1, plus instead of N2, I'll write M2 V2, and instead of N3, I'll write M3 V3. Just keep that in mind, that unit of volume on the left hand side in V1 and V2 and on the right hand side of the equal to in V3 has to be same. Either keep it in liter or milliliter or meter cube, but they have to be the same unit, right? So if I just put the value of M1, this is like 1 by 200 molar into volume V1 is 10 ml. I'm putting it in ml, everywhere it is ml, so let's keep it in ml only. Okay. M2 is like 1 by 200 molar into V2 is 40 ml is equal to M3. We have to calculate this into volume. V3 is going to be 40 plus 10, right? V1 plus V2 will be V3. V1 is 10, V2 is 40, V3 will be 50 ml. Okay, into 50. So if you just solve this, 210, 240. Okay, this will be like what? 1 by 20 plus 4 by 20 is equal to M3 into 50, right? So this will be like 5 by 20 is equal to M3 into 50, 5, 10, M3, 200, 1 by 200, right? M3, 1 by 200 molar. But is this going to be your answer? No, no, no. We have to calculate the pH value, right? So if I say H2SO4 dissociates into 2H plus and SO4 2 minus, right? 2 minus. So if you just read the stoichiometry, if it is like 1 mole of H2SO4, it is going to give you 2 moles of H plus. If it is 10 moles of H2SO4, it is going to give you 20. If it is X, this will be 2X. What is the molarity of H2SO4? You have 1 by 200, right? Keeping that in mind, so this will be like 2 into 1 by 200. That will be 1 by 100. Nothing but 10 to the power minus 2 molar. This is what? This is the concentration of H plus ions in the final mixture solution, right? Okay. Okay. pH. Formula for pH is minus log of H plus. So can I say minus log of 10 to the power minus 2, and 2 minus 2 will come in front, minus minus plus 2 into log 10. Log base 10 is to 10 will be 1, 2. Answer is PH is 2. Option number C is going to be the right answer to this question. And with that, we conclude this question. Thank you. Yeah, so here we have a question on IUPAC nomenclature. Let's see what the question says. The correct IUPAC name of the compound is, and you see this beautiful compound in front of you. Okay. What I can observe is that there is an unsaturation here. So very first thing, this double bond has to be the part of the parent chain, right? So the numbering is going to start from here, right from here, right? Okay. So 1, 2, 3. Now the question is where we are going to proceed. So the longest chain rule. So if I move this side 4, 5, 6. Okay. Okay. If I go from 4, 5, 6 here. Okay. Okay. And if I go from 4 to 5 and 6. So everywhere it is 6. So longest chain is a tie case. So what we have to keep in mind is choose that chain where there is more number of substituents, where the side chains are more. So if I just keep that in mind, I have to neglect this one. Why? Because if I go this way, if I choose this as my parent chain, then observe carefully, there'll be only one substituent. Not acceptable, not acceptable. So I'll remove this. So let me remove this as well. So either this or this, and what I can observe is they're exactly same, so you can take any one of them. So let's take this. Okay, so this is how we're gonna number it: 4, 5 and 6. Now you have two substituents. This is an ethyl substituent, right? And this is 1, 2, 3. 1 prime, 2 prime, 3 prime. So this is your propyl substituent, right? Okay, okay, fine. The location for ethyl is 4. It is at 4th carbon atom, and propyl is at 3. So the word root 6 carbon atom, the parent chain is 6 carbon atom long. So the word root will be what? This is like hex, and double bond is at location 1. So it is up to you either to write it or not to write it, right? It is very similar to either you write 1x or x. Both are same. So it is up to you whether to write it or not to write it. So hex 1-ene or hexene rather. I'll prefer hexene. So my final name will be 4-ethyl. Why ethyl first? Although sir 3 propyl, 3 comes first, 3 comes before 4. But if you have side chains, you have alkyl substituents, then you have to follow the alphabetical order. Okay. And E comes before P. That is why the name of the compound is going to be 4-ethyl 3-propyl hex 1-ene or hexene, right? So let's match with the options. 3-ethyl 4-ethynyl. No, 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 no. 3-ethyl 4-propyl. Oh, ho, ho. This is the reverse. 4-ethyl 3-propyl. Incorrect. 3,1-ethyl propyl. No, no, no. 4-ethyl 3-propyl hex 1-ene. Perfect, perfect. Absolutely matching with option D. D for Delhi, D for Dehradun is the right answer to this question. And with that, we close this question. Thank you.